All right, so in this video, we're going to be doing foci for our graph. So we're going to graph it and also plot the foci. So again, what we talked about is our foci are the 2 points that all the points have a same distance from the sum of it. So if I were to take the distance from P to this pen and Q to this pen and add them up, no matter where I place that pen on the ellipse, it will always have that same distance total from P and Q. So where are they located? We just use the A and the B. So if you remember the denominators, these are our A's and our B's. So for our first one, our A squared is 9 and our B squared is 4. So that would give us an A of 3 and a B of 2. And so if you remember graphing this, we centered at 0, 0, and we go 3 units for X, 2 units for Y, and we draw our ellipse. So now what we're also going to do is put our foci on there. And what you want to do is, what it really is this: C equals the square root of larger squared minus smaller squared. And where they go is on the major axes. So that's why we have A here. So if A is the major axis, then we do A squared minus B squared. And if B is the major axis, then it's B squared minus A squared. All right, so let's plug it in. So 3 is larger, so that would be 3 squared minus 2 squared. So that's 9 minus 4. So that's the square root of 5. So our foci are located at the square root of 5 from the center. So if we have our center at 0, 0, our major axis is X, right? Then we would add that square root of 5 to it, to the X. Oops, sorry, I got ahead of myself. And you would get the square root of 5, 0. Now to find the other one, you do the same thing, but we subtract the square root of 5. And you end up with negative square root of 5, 0. So that is where our foci will go. They go on the major axes. All right, so I'm going to put them in red. So square root of 5 is 2.23. So it's approximately 2.23, 0. And negative 2.23, 0. So right about here and here. And so that foci would be our square root of 5, 0. And that foci would be our negative square root of 5, 0. So let's look at Desmos. And you can see this a little bit more, and then we'll try some more. So here we have an A of 25. So again, that's 5 and 5. And 16 would be 4 and 4. And so you can see they're at 3 and 3. So I have it in over here. I have an A squared minus B squared and a B squared minus A squared. And you see one is undefined. And that one is because our B squared is smaller than our A squared. So we're getting an imaginary number here. So they're not showing up. All right. And so the same idea, if I were to move this over, shift it up and right, we now have 4, 3. You can see it's minus 4 and minus 3. But our C hasn't changed because it's only based on the A and the B, and I have not changed them. So it's still 3 units. So you can see I have taken 3 units and I've added it to the X. So 3 units plus 4 is 7. And 4 minus 3 would be 1. So you add the 3, subtract the 3. And so if I change my A and B, I'm going to make my A a little bit larger, so it'll change it now. So what you can see is now we have a difference of 5.75. So it's 5.75 this way and 5.75 this way. That is our C. So we're taking our vertex and we're adding the C to our X coordinate, and we're adding the C to our negative X coordinate. Our subtracting the C from the X coordinate. Now, what happens if it works the other way? You can see now our foci are on the Y axis. So if the Y is larger than the X, the foci are on the Y, and so whatever I get from my C, I'm calling it D in this case, is 4.89. So by plugging those numbers in, we get 4.89. And so you can see we're taking the Y coordinate now and adding 4.89, and taking the Y coordinate and subtracting 4.89. So let's take it back down to 4 and 5, because I know that'll be 3. So you can see it. So our C here is 3. Our Y is larger, so our foci is on the major axes, which is for our Y, right? And our D is 3. So again, the Y plus 3 and the Y minus 3. See, the foci. That one's plus 3. So we take our 3, add 3, take our 3, subtract 3. So it's always the major axes. Let's try some more. Okay, so on the next one, our a here is 9. And again, a always belongs to the x. That's all we're doing. That's all we're saying. So our a here would be 3, and our b is 2. But we are now centered at 3, comma, negative 4. So let's plot that. So 3, negative 4. And then the a, we're going to go 3 right, 3 left, up 2, down 2. So you can still see that our major axes here is x. Right? So we would then take, right here, this is our major axis is x. So we will do the square root of 3 squared minus 2 squared again. And so that's 9 minus 2, 4, sorry. That's the square root of 5. And so we'll do the same thing, but this time we're going to add square root of 5 to 3. That would give us 3 plus square root of 5 minus 4. And again, that's approximately 2.23. But then to get the other focus, we're going to take that 3 and we're going to subtract the square root of 5. So we get 3 minus square root of 5, comma, negative 4. So all you're doing is taking your c and you're adding it to the larger one. So whichever went first, that's the important one through this entire thing. 3 is bigger, so we add it to the 3. And so our foci would now be at 2.23 again. Right, it's 2.23 away from 3. So if we're at 3 here, right, they would be 2.23 to the right and 2.23 to the left. If you look at it, it's exactly the same ellipse. We've just shifted it because that's the only difference here. Your A and B are the same. So the foci are going to be the same distance from the center on the same axes. All we've done is shifted it. So now we know that that foci would be, that's the 3 plus rad 5, comma, negative 4. And that one would be the 3 minus rad 5, comma, negative 4. So we're going to go rad 5 to the right, rad 5 to the left. And that's it. So looking at Desmos, you can see here it is, right? And so this is our graph, and there are our two foci. And so all we've done is shifted it. So if I took this back to 0 and this back to 0, that's our ellipse from before. Say the 2.23, same A, same B. But I've shifted it down 4 and right 3. So it's just centered from there. So whatever you get for your C, your 2.23, we're just adding it to 3 and subtracting it to 3 along the major axes. So if I were to switch these two and say, oh, let's make B3 and A2, it's the same ellipse, just rotated, right? And so you can still see it's still that 2.236, that's square root of 5. And so now we're just adding it to the y coordinate. So the negative 4 plus. So this one right here is, this would be 3, comma, negative 4 plus the square root of 5. And then this one down here is 3, comma, negative 4 minus the square root of 5. So if the major axis is y, you're just going to add that c to the y axis. So he's bigger, it goes on that value. That's it. All right, so let's try one more. So we're going to divide this one here. We have to set it up. So we're going to divide by 144, divide by 144, divide by 144. And so we end up with x minus 2 squared over 16 plus y plus 3 squared over 9 equals 1. And so you can see, again, this one is still major axes is x. So a equals 4, b equals 3. So we're dealing again with x. So this would become square root of 4 squared minus 3 squared, which is 16 minus 9, which is 7. So that is now our new c. Our c is equal to 7 here. So from our vertex, and we are centered here at 2, comma, negative 3. So we go to 2, negative 3, and then 4 left and right, like that. And 3 up and 3 down. So you can see that our major axis is still x on this one, not y. And so we will be adding it again to the x value. So let's do it a little different. We're going to subtract rad 7. So now this would be 2 minus rad 7, comma, negative 3. And then the other one, we're going to add rad 7. So I'm putting the one on the right as the add and the one on the left as subtract. So that's where our foci go. And so what is the square root of 7? It's 2.6, we'll say 2.65. So it's approximately 2.65. So from the center, you're going to go over 2.65. So 1, 2, and then a little bit more right there, and then 1, 2, and a little bit more. And so this one would be 2 plus rad 7 minus 3. And this one would be 2 minus rad 7, negative 3. All right, and that's it. All right, so let's do one more. This time, we're going to make this a y-axis problem. So our major axes will be for the y. So we're going to make this one 25, and this is 16 equals 1, and let's shift it. So we'll do x minus 4. Let's go to the other way. Minus plus 4, and y minus 3 squared. And so we're going to shift this now left 4 and up 3. And let's look at it first in Desmos and then work it all out. So this is our graph. So we have the x plus 4 squared and the y minus 3. So it's been shifted. And 16 and 5. So if you look at our c here, it gives us 3. So in this case, our y is bigger. So we are now going to add the c to the y-axis. So you can see it was 3. That was our y value. Our c came out to be 3, and so it's 3 plus 3 and 3 minus 3. So our a here is 4, and our b is 5. And again, this is our major axes now. So we're dealing with the y. So when we find our c, we're going to go to the square root. We have to put the b first this time. So this would be 25 minus 16, and that's 9, which is 3. So our c is equal to 3. So we take our new center, which is negative 4, 3. And since it's y-axis heavy, we're going to add and subtract 3 to the y. Okay, so we go minus 3. So that would be negative 4, comma 0. And then we also are going to do plus 3. So that would be negative 4, comma 6. Those are your new foci. So your graph would look like this. See our negative 4, 3, and then up 3, down 3. How we added. There's negative 4, 6, and there's negative 4, 0. Negative 4, 0, and negative 4, 6. So you can see that the x didn't change at all. So it's always the major axes. That's the one you look for. Thank you.